Hi, everybody. Just real quick, going to break these down, a couple other notational issues that I wanted to cover, and actually treating this coordinately, which I did not do in class. So, couple things going on in this first example. I want to go quick because it's on YouTube. You can rewatch and all this other stuff. But here we go. We got a new notational thing. Did end the notes by telling you that if it said like D, just the 1/2 of QRST, I don't have the time to write that. That just means, dilated from the origin being the point. The origin is the center of the dilation that you do. But this one has a different notation. So it is a dilation of 1/2. We are going to still have that going on, but using R, an actual vertex, as the center of the dilation. So there's a couple ways of doing this. When you have it on a coordinate plane, though, I think it's easier than if you looked at the notes in the book. And not that you can find it, because believe me, I had a hard time finding it myself. Don't want to get into that. I'm going through my own issues right now, being COVIDed at home and all that other stuff. I'm fine, going through the protocols, but okay. So it's using this as the center of the dilation. And then with a coordinate plane, this makes this real easy. 1, 2, 3, 4, 5, 6, 7, 8. When I use this as the center of dilation, sure, we could, treat it like we did it in class. Draw the dotted lines, and then along these lines, we do the dilation. So this makes it a lot easier with a coordinate plane. And I think this is the only kind of question I would ask you in a test with a graph given in a coordinate plane, so you could do your counting very easily. Because if these are 8 away, all I would do is go 1, 2, 3, 4 away, and then that would be Q prime. And then I could actually do what we did with the second method, doing like parallelness. Parallelness situation says fine. Now from there, draw from here to here, and then keep going and go from here to here. And then we're done. But then another way of doing it is this. This is 6 away, so then going 3 away is F prime. So this is putting both methods in there, either the parallel method I like to call it, or measure all of them. But then this one's kind of tough. You can't measure along a diagonal. So after we draw this, we probably just put that last point here. But this is pretty easy. 1, 2, 3, 4, 5, 6. I'd have to go up here though, and then go 3 away from that one to make that connection there. So all that happens is you get a dilation, but using one of the points on the actual graph, I guess we could call it, or image in the coordinate plane as the center point. So just to understand the notation is the point of that. Much different than this. This implies that the origin is the center of the dilation. Okay, that should be good there. Oh boy, I have a hard time ending these videos fast.